Hello, everyone. This is Mrs. Freeze. I hope you are all doing well and you're keeping yourself busy and up to date on all of the math that is on the website. Thank you so much for all the encouragement and questions that you are sending me via email. Please don't hesitate to email me with any questions or concerns that you have. Okay, today we're going to do notes on Chapter 10, Lesson 8, Probability of Compound Events. A compound event is when there are two or more simple events. Compound just means more than one. We are going to learn how to make tree diagrams today. A tree diagram is a way to count all of the outcomes in a sample space. Not only will we make a tree diagram, but we will also be making a sample space. Here's our first example. A pet store sells aquariums in 3 shapes: hexagon, pentagon, and rectangle, and 2 sizes, 10 gallons and 20 gallons. How many different fish tanks can be made from the different shapes and sizes? The first thing you want to do when you are going to be making a tree diagram is to list your events. Now, if you remember from the fair unfair games, some of the events that we had were coins and die. In this case, the events are the categories of what is being offered for the aquariums. The first category are shapes, and there are 3 of them. And the second category they're offering are sizes, and there are 2 of them. So you want to list your events. Shapes, there are 3. Size, there are 2 different options. Now we know from what we talked about in the theoretical and experimental probability that in our sample space or total outcomes, we're going to have 3 times 2 different options for these aquariums. There will be 6 different options. So you have your events listed. Let's look at our first event, shape. It says we have a choice between hexagon, pentagon, and rectangle. So under shape, in preparation for my tree diagram, I'm going to list the 3 different options for shape that I have. And because we're making a tree diagram, I've got some good space between my event and each of the choices underneath. So space this out pretty good because a tree diagram takes some space. Now, if I choose a hexagon, I will have 2 different options for sizes, okay? So we're going to make some branches here, hence the name tree diagram, extending from each of my shapes. Okay, so make your branches. Now, if I have a hexagon-shaped aquarium, I will have the option of having a 10 or 20 gallon size. If I have a pentagon shape, I will have a 10 or 20 gallon option. And if I have a rectangular shape, I will have a 10 or 20 gallon option. So now I've listed everything under my events. You can see we talked about 3 times 2 possible outcomes in this problem. You can see that there are 1, 2, 3, 4, 5, 6 here. This is not my sample space, but the last column always shows the total number of outcomes as well. Now I want to make my sample space. My sample space comes from my tree diagram. Up here, if I bought a hexagon, I could buy it in a 10 gallon, or I could buy a hexagon shape in a 20 gallon. So there's my first 2 options in my sample space, hexagon and 10 gallon, hexagon and 20 gallon. If I go down here, pentagon and 10, pentagon and 20 are another 2 options for me. And last, if I bought a rectangular shape, I could buy it in a 20 gallon size or a 10 gallon size. And there is my sample space. My sample space just contains all of the combinations that are available to me. Okay, let's try another example. You flip 3 nickels. What is the probability of flipping exactly two heads. So we're going to make a tree diagram again. Remember, on the last example, the first thing we did was we listed the events. Remember, the events are the things that you're using in your problem. In this case, we're using 3 nickels. We have 3 different nickels. So our events are the first nickel. Options are heads and tails. We have 2 options there, or outcomes. Second nickel, again, we can either flip a heads or a tails, 2 outcomes on the second nickel. Third nickel, again, 2 outcomes, a heads and a tails. Okay? All right, under your first event, list your outcomes, heads or tails, and then start making your branches. We're going to build our tree diagram. So if we flipped the first nickel and it landed on heads, then the second nickel could be heads. But if we flipped the first nickel and it landed on heads, we could also flip the second nickel and it could be tails. But if we flipped the first nickel and it was a tails, the second nickel could be a heads, or it could be a tails. Okay? Now, each one of these, we have a first flip, a second flip. Now we're going to do a third flip. So we need a branch coming out of each of these options, because if I flipped a heads on the first flip, a heads on the second nickel flip, I could either do a heads or a tails on the third flip, right? So each branch, again, heads and tails. If I flipped a heads on the first, a tails on the second, I could flip a heads on the third, or I could flip a tails on the third. So this is how our tree diagram will look as it's completed. Now let's go back up. We know in our sample space, we're going to have 2 times 2, which is 4, times 2. We should have 8 different combinations in our sample space. And you can see there are 8 different things here underneath the last event on our tree diagram. Okay, let's make our sample space. In the sample space, I have these 2, and I'm going to show you how I got those. I'm going to go back to my first nickel. I have a heads, and a heads. That's one combination. I have a heads, and a tails. That's my second combination. Okay, let's look at more combinations in my sample space. I could flip a head on the first coin, a tails on the first coin, and a heads on the third coin. That's how I've got this right here. Or I could flip a head on the first coin, a tails on the second coin, and a tails on the third coin. Take a moment and finish the sample space. We have 4 here. We should have 8. Go down to this part of the tree and finish the sample space. Pause the video while you do that. Okay, you should have come up with this. We could have flipped a tails on the first coin, a heads on the second coin, and a heads on the third. We could have done a heads, and a tails, a tails, and a heads, and a tails, and a tails. So this is my sample space. These are the possible combinations of flipping 3 coins. Now the question is not answered quite yet. It says, what is the probability of flipping exactly 2 heads? Well, I can see that right here I have 2 heads, right here I have 2 heads, and right here I have 2 heads. So 3 times out of the total 8 times that I flipped my coins, I was able to get exactly 2 heads. That gives me 3 out of 8, or 37.5% probability of flipping exactly 2 heads. if you remember the probability number line from lesson 6, it would be unlikely to flip exactly 2 heads if we were talking about the likelihood of it happening. So the next thing you're going to need to know is something we've already been talking about, but we have not given it a name. It's called the fundamental counting principle. And this is just used to determine the total possible outcomes for compound events. So total possible outcomes is just found by multiplying the number of outcomes for each event. And like I said, we've been doing this. Now we're just giving it a name. So let's look down here. It says find the number of possible outcomes of flipping a coin and spinning a spinner. Now remember, you want to start by naming the events that you're given. In this case, what are the events? They are the coin, which has a heads or a tail, 2 possible outcomes. And they are the spinner, which has 5 different colors. So in order to find out the total number of outcomes, just like we've been doing, it is 2 times 5, which gives us 10 total outcomes. Please take a moment, pause the video, and complete this question. Remember to always start with the categories of the events that you're given. All right, so it says that we have options for these tennis shoes of gray or white. So one of our events is color, and they give us an option of 2 different colors. And we have 3 different sizes. Our other event or category is size. We have 3 different sizes. So we have 2 times 3 total options, which gives us 6 total options. Okay, this is a little bit different because now we're looking at some compound events here and the probability of having something happen for each event. It says Lamar is going to spin each spinner once. What is the probability that he will spin red and the number 9? Now, we have 2 events here. The first one is we have a color spinner. The second event is we have a number spinner. So we have a color spinner and a number spinner. But they're asking what's the probability that he will spin red. Well, I have 1 red out of the 5 colors on my spinner. So 1 out of 5. And the number 9. And both at the same time when we spin. So look over here at my spinner. I have 1 number 9 out of the 10 numbers. I'm going to go ahead and multiply my 1/5 times my 1/10, and that is going to give me a 1/50th probability that Lamar will spin a red and a 9. All right, here are 3 problems that I'd like you to pause the video and complete. When you are done, please check back because I will have the answers for you. Okay, the first one, 3 number cubes are rolled. What's the probability of rolling 3 5s? Well, there's only 1 5 on each cube, right? 1 out of 6 on cube 1, 1 out of 6 on cube 2, and 1 out of 6 on cube 3. That gives us, we multiply all of those together, and that gives us a 1 out of 216 chance of rolling 3 5s. Again, we started with the events that we had, cube 1, cube 2, and cube 3. The second one says Elisa can take 6 different classes first period, 2 different classes second period, and 3 different classes third period. What is the total number of outcomes? Well, my 3 events are period 1, period 2, and period 3. There are 6 different choices in period 1, times 2 different choices in period 2, times 3 different choices in period 3, giving us a total of 36 outcomes. This last problem, I have put the explanation for this problem here. And you can take a few moments and read. Here's the problem right here, and this right here explains exactly how they got to the answer of 1 out of 4. Have a great day, and please don't forget to email me with any questions or concerns that you may have.